I'm going to talk about UML and Ada. In particular, I'm going to talk about UML2, which is a major extension to UML for modeling large-scale systems. So whereas some of the presenters are talking about safety-critical, high-integrity systems, I'm going to talk a little bit more about large-scale systems and some of the modeling support in UML2 for supporting those kind of systems. Before we do that, quick introduction. Why do we do modeling? Well, maybe we don't. We all have legacy systems that have been going for 10 years. Right, here's a modeling tool. It's called plasticine. It's quite easy to train yourself to use it. Generally, the approach to training is to learn to roll, because from rolling you can create all sorts of things. So let's model a system together. Using plasticine. Right, let's build a footballer. What does a footballer need? Okay, he needs to be able to kick the ball. So let's give him some legs. Okay, he needs a head, a very big one. Give him a yellow head. And he needs a dodgy haircut. Okay, there's my system. Okay, I've modelled it. Everybody happy with that? Can anybody spot any obvious problems with my system? No arms. Okay, so one benefit of visual modelling is that we can collaborate to find problems earlier. Okay, he needs some arms. Okay, there we go. We can also understand the context in which the system operates. This is a Premier League footballer. So as well as the haircut, he needs to kick the ball, or in the case of some Premier League footballers, handball, goals. So we can look at this system from the perspective of the things that are outside the system. In UML we call those actors. Actors are things outside the system that interact with the system, which is why we use cases to find those problems. What is another reason why we model a system? Well, it's an obvious one, isn't it? So far I have a system that consists of a number of components. I've done a very abstract model. I've designed the system from an abstract level to understand the context of the usage. Having designed the system, including the components and including the interfaces, I can develop it in parallel. Okay, so who's going to develop a leg? Leg? Anybody else? Arm? Okay, legs, arm supplier, leg supplier. You've got 30 seconds. Okay, can you do the body? It's a Premier League footballer. Can you do the head? Okay. So the idea of a visual modelling language is we can communicate. Okay, it's not about talking to a machine. It's about talking to engineers and talking to customers. Okay, we can communicate visually. It enables us to find problems. A picture paints 1,000 words. How are my supplies doing? Okay, one leg, cool. Okay, how are we doing with the arm, hand? Okay, arm. Where's the body? It's easier to integrate the body first. He's lost some weight. Sorry for the lack of requirement definition. Interesting, he now looks like, is that any particular footballer?
He's a Premiership footballer. So.
All right. I'm missing an arm and a leg. There's always people late in delivery, aren't they? That's fantastic. Okay. So I can use the skill of many people to solve a very large, complex problem. Okay. I'm using your specialist skills. I would never have dreamt of designing it like that myself, but there we have a Premier League footballer. So that's the purpose of modelling. Let's look at some of the support within UML for modelling. Now, who knows what UML2 is? Who knows what UML is? How many people, keep your hand up if you use modeling? All right, oh, cool. So, big thing, UML2 changed. It changed in 2005 to add some additional language. What was the problem with UML1? What? I'm slightly deaf, so you have to shout.
No semantics.
No semantics. Oh, that's a compiler vendor talking, I'm sure. Problem with UML1 is actually, it's about UML object-oriented modeling. It's about collaborations of objects and how do we notate those collaborations. So it's very good at object-oriented design. Object-oriented design was an antithesis to structured design. It was trying to do the opposite thing to what structured design was doing. So UML had very good support for modeling interactions between objects. Using a class diagram, you can model the object-oriented constructs like associations, aggregations, compositions, dependencies, generalizations. So these are the ways in which UML allows you to glue objects together. Now in UML1 you could use an interface. However, it wasn't very good at structuring a system. So UML2 added support for building large-scale systems. In particular, decomposing systems into subsystems and subsystems into other subsystems. Hierarchically decomposing a system into components. The notion of composite class is one which comprises of a number of parts. Here we have an alarm controller which has a number of subsystems. The subsystems are instances of classes that exist within this particular class. So that's the notion of a part. These are parts, and parts are connected to other parts. And you can do it through a named connection point called a port. So here we have a port. The port requires an interface. Where is that interface? The interface is actually provided by this piece of hardware. So we can effectively decompose or separate our system from, or the components within our system from other components. We can also separate our higher level system. It allows us to do what we call hierarchical decomposition of our system. Which is why we're getting to ADA 2005 in a minute. In UML, there is a concept of an interface. An interface is a collection of operational signatures. So effectively provides me with an abstract definition of what the operations are without any concrete realization. A class will realize that interface somewhere within the composition. So I can do what is called assembly. I can take, create a little builder class here, composite class. I can put instances of other classes inside of it. These things already have ports, okay? And I can say that this particular class requires an interface. This particular class provides that interface. Now there is actually no association between these parts. Okay, they are independently created. But I can use the composite structure to place them in a particular context. Not only can I place them in a particular context, I can automatically get the tool, or a UML tool, to create the composition for me, together with the wiring code that forwards the messages between ports. So I can effectively put a connector in and run the system without changing the implementation of either the receiver or the transmitter.